Welcome to Module 16 of our complete structural design of one-story building. So we will continue from where we stopped in Module 15. So today our focus will be on taking bar bending schedule for solid slab. So the last bar mark in the column is 07. So we continue from the slab. So this is our 08. Okay. So we have our slab, floor slab detail. So 08. 08 is the bar mark. Then the bar size is Y12. So this is the Y12 that we have. Now before we continue with this, let me clarify 2 points here. Now for us to have the length of the returning bar, of this continuous edge, we will multiply the length, the adjacent length, with 0.15 for us to have the length of these returning bars. The guide is that this span, which is 1725, must be multiplied by 1.15 for us to get the length of this. Now for the interior support, for you to get the length of this top reinforcement, you have to multiply this adjacent span with 0.3. So that is the rule. But practically, sometimes we don't really follow that, because if we follow that, sometimes we might waste the reinforcement. So what I personally do with my wealth of experience in structural design and construction, once I look at the span as it is now, for instance, if I calculate this, if you calculate if you multiply 1725 by 0.15, so you will have about 225 something. So by the time you adopt 25, or let's say 300, and you notice that there are some of these span that are greater than this one. Understand? So what I normally do, once I will look at the most critical, then multiply by the most critical span, then whatever it gives me, I will just go for the practical length of returning bar, so which is like 1000 or 1200. So here we will adopt 1000. We will adopt one, because this is a practical design. So we will adopt 1000. So now the theoretical guide, the theoretical aspect of it is only to give us a guide on what we should do. So it should not be less than that. So in a practical situation, if you have the experience, you can actually take division aside. So we are going to adopt 1000 for this. Okay. So we have established that for the discontinuous edge, that the length of the returning bar should not be less than 0.15 times L. L is the adjacent span of the slab. It should not be less than that, but it can be greater than. Then for the interior support, it should not be less than 0.3 L. So that is what will be guiding us. Okay, so 08. So we have the diameter here is 12. Then number doors is 2. Why is it 2? When you look at 08, when you look at this slab, you know that this slab is symmetrical. That is, the arrangement that we have on the left hand side is also the arrangement that we have on the right hand side. So in that case, instead of us to waste our time to repeat the same reinforcement here during our detailing, so we simply detail the left hand side and now give an information that will help us to adopt the same. So we say here repeat same reinforcement as on the left hand side. So when you have number doors, since we know that number doors is actually the numbers of the reinforcement in the project or in the drawing, so here the number doors here is 2 because we have this or this arrangement on this other side. So 08 here is not 1, it is 2. So we have the same arrangement. So what is obtainable here will also be obtainable here. So under number doors we have 2. Under number doors we have 2. Then number in each is 6. Number in each is 6. So when for you to get total number, you multiply 6 by 2 to have 12. Okay, so here we look at the shape of this reinforcement. So this is the shape. You can copy out the shape of this reinforcement for you to really ascertain it. So this is the shape, so that this how it look like. Okay, so and this is the shape of it. So let's get the length of the reinforcement, which is this one. So let's get that length. So for us to have the accurate length, what we do is for us to take a dimension from here to here. So this will give us 5775. Okay, now the dimension we are taking is out to out. So but the reinforcement is not going to be placed from out to out. Rather, there will be a cover. So there will be a cover. Mind you, this is the formwork. This is the formwork. So this is the formwork. So there will be a cover from this formwork to somewhere here, that way we have the reinforcement. So for the beam we adopted 25. We adopted 25. For the slab we adopted 20. We adopted 20. If you can go back to the slab design, you see that we adopted 20 mm cover. So by the time we subtract 20 here and also subtract 20 here, so that will give us 40. So we now say that 575 minus 40, so that will give us 5735. So 5735. So we come here, we say that this is 5735. 5735. Okay, now the slab thickness is 150. The slab thickness is 150. So this is the slab thickness is 150, and we adopted 20 mm cover. So by the time you subtract 20 mm, by the time you subtract 20 mm from the bottom and also subtract 20 mm from the top, mind you, this is where the reinforcement is. So this is where the reinforcement is. So you subtract 20 from the bottom and also subtract 20 from the top, so that will give us 40, and the thickness of the slab is 150. So by the time you subtract 40 from 150, you end up having 110. That is why we have this 110 here on both sides. So the next one is this returning length of the bar. So we have established that our returning length bar should not be less than 0.15 L for this continuous edge. Then for the top, which is the interior support, the length from the center of the beam should not be less than 0.3 L. So we have already calculated this. And when you check out this, because this bar is going to run from here to here, so when you calculate this, we end up having 258. And when you also do this for this other span, for instance, let's look at this one here, so that we know exactly what we are doing. So let's look at this one. So you see this one from here to here is about 5550. So 5550 times 0.15. So we have 832. Now 832 is not a round figure, so we can adopt 850, which is a round figure. We can actually measure it outside. So if we choose between 850 to 1000, then it is okay. So in this case, because of this, we are going to adopt 1000. Now we are doing this in order so that we can avoid wasting of the reinforcement. This is a practical design. So here we are going to adopt 1000 as the returning bar, as the length of the returning bar. So here we use 1000. And also 1000. Then let 0.15 L be your guide. Let it be the length of this returning bar should not be less than 0.15 L for discontinuous edges, and should not also be less than 0.3 L for the interior support. Okay, so at the end of the day, we are going to add up everything here. So we have 110 plus 110 plus 2000 plus 5735. So we have 7955. 7955. 7955. 7955. Okay, so let's calculate the total quantity. Total quantity will be this time this, this time this, so times 12 divided by 1000. So this will give us 95.46 meter. So we can convert this to 96 meter. Okay, so we are done with 08. So we move to 09. Now 09 is wide 10, the diameter is 10, the diameter is 10, so this is top distribution, this top distribution. So we have it here. 09 is that the size here is 10, then the number does is 2, the number in each is 5. Each is 5. So when you multiply this by 5, it gives you 10. So let's get the length of the distribution bars. Let's get the length of the distribution bar. Now there are two ways that you can actually calculate this. There are two ways you can calculate. Either you take direct measurement, or you use the method of 0.15L to do the calculation. So if we are going to adopt 0.15L, it simply means that since we adopted 1 meter from here to here and also 1 meter from here to here, so what we need to do right now is for us to get the overall length of this span, which is 5550. So by the time we get 5550, we subtract 2000 from it. 5550 minus 2000. So we will have 3550. Mind you that we have distribution bar that distribute from here to here, and this one distribute from here to here. So the length of this bar is 3550. So we come here, we now change this to 3550. So we calculate the total quantity. So this will be 10 times this, 10 times 3550. We divide this by 1000. So this will give us 35.5 meter. So we can pick 35, only 36, complete 36. Okay, so that is for 09. So let's move to 10. So 10 is this one. 10 is this one. So the number in each is what? The number in each is 11. The number in each is 11. Okay, so we have 11. Then number does is 2. So this gives us 22. So the shape of this reinforcement, let's look at the shape of the reinforcement. So the shape of the reinforcement is like this. This is the shape of the reinforcement. So this is the shape of the reinforcement. So let's get the length of this. So we pick our dimension, and this is 9375. 9375. Okay, 9375. Now this 9375 is out to out, out to out. So we assume that from here that we must have a projection of 300 so that it can overlap properly. It can overlap with this one. So we also project this 300. So by the time you join the two, you can tie them. So we will add that 300 to what we have here. We will add it to 9375. So 9375 plus 300. So this gives us 9675. And mind you that we took the measurement from out to out. So we have to subtract our cover of 20. So minus 20 cover. So this will give us 9655. 9655. So we go back to the schedule. Okay, 9655. So fine, we have gotten that. Then the length of the returning bar is 1000 that we have adopted is 1000. So when you add that up, you will have this. So when you add it up, you have this. So for us to get the entire quantity, we multiply this by 22. So 10, 7, 6, 5 times 22 divided by 1000. So this gives us 236.8. So two three six point eight. So we can 237. So we are done with 10. So we move to 11. 11 is Y12. 11 is Y12. So let's identify the reinforcement. So this is the reinforcement. Okay, so let's copy the shape out so that we don't make a mistake. We copy the shape out so that we can represent the shape properly. Okay, so this is the shape of the reinforcement. So 11 is Y12. So diameter here is 12. Diameter here is 12. And number does is 2. The number in each is 19. So you multiply 19 by 2 to have 38. Okay, so let's calculate this. Let's calculate the shape here, the length of that shape. So as we normally do, so we pick our dimension from here to here. So we have 7,500. So you take note of that. 7,500. So you add the 300 projection or lap length. So when you add that, we have 7,800. Then you subtract 20 from it, minus 20, which is our cover. So this gives us 7780, 7780, 7780. So that's why we have 7780 here. Okay, so the length of the returning bar, we adopted 1000. So here we will edit this to 1000. Edit this to 1000. So I think I've been able to explain this to us. I've been able to explain it. Now, when you calculate the length of these returning bars using the formula 0.15L, take for instance, if it gives you like 500 or 520, so what you need to do is you can pick something that is higher than that 520. You can pick something like 600, but the length of these returning bars should not be less than 0.15L. Should not be less than 0.15L. Now, for practical reason, you have to adopt something that will be in uniform. So in other words, you should not just say, okay, because you want to take for this span, just come and calculate for this. If this one gives you, let's say 1200, so you are going to distribute 1200 from here to here. Why this one 600? No, it doesn't make any sense. Instead, you look for the most critical, then adopt the uniform spacing for all. So if you're adopting 1000, it means that you are going to distribute from here to here 1000, and you will see the beauty of it. So I needed to explain this so that some of us might not misunderstand me. So okay, so we have, so here we edit this to 1000, edit this to 1000. So we need to add it up now. So 1000 plus this plus 1000. Okay, plus 110. Okay, so 8890. 8890. 8890. So to get the total quantity, we multiply this by 38. Simply multiply this by 38. So this will give us the value. We divide this by 100. Okay, so this will give us 337.8. So we can approximate this to be 338. So now let me also pause here and explain something. You see, this length, this 8890 is in millimeter, and it is the cut length of this reinforcement. So if you want to give a steel bender the cut length, so what you do, you just come to the bar bending schedule table, look for the bar mark, which is 11, and just tell him that he should cut 8890. By the time you cut 8890, he will be able to bend this and achieve this shape. This is just the cut length of it. So because by the time you add this up, you have this. Okay, so we are done with that. So let's move to the next bar mark, which is 12. The next bar mark, which is 12. I have to take time to show us this, so that even when you are using soft weights, you know how soft weights arrive at those shape and length of reinforcement. It's not really far away from what we have done. It's not really far away from what we have done. Okay, so let's go to 12. 12 is 12. So 12 is actually a top reinforcement. So it's top reinforcement. So it has 19 in each number does. So 12. Number does 2, 19. Multiply this. We have 38. It is actually a straight bar. So let's look at actually a straight bar, which is this one here. So we have already calculated the length of the top bar from the center of this beam. So we have 1200, and we also have here 1200. So we add this up to this, it will give us 2400. Then we add this up, we add 1725. So when you add that, you will have 4000. You will have 4125. So you multiply 4125 by 38. 125 by 38. You have 15 this. Then you divide this by 1000 to convert it to meter. So this will give you 156.75. So we can take 157. Okay, so we are done with that. So we move to 13. Thirteen is, let's identify 13. Okay, this is 13. 13 is actually top distribution reinforcement, and it is 16 in each. Okay, so let's go and reconcile that. 13, 16, okay, 32. Okay, so let's calculate the length. Remember, I told us that we can use direct measurement, and we can also use the method of calculating the adjacent edge by multiplying it with 0.15 and 0.3 L respectively. So in this case, what we will do is for us to take the direct measurement. So we are going to take direct measurement. Mind you, this is distributing this top reinforcement from here to here, and if you want to go by that calculation, because we have a distribution bar on this direction. So let's assume that it is 1000 here. Then we have this one here to be 1500. So let's calculate the remaining length of that distribution bar. The remaining length of the distribution bar will be, okay, this is 4725 minus 1000 minus 15. So this reinforcement, the length of this reinforcement here from here to here is 2225. That is 13. So we multiply this by 32. divide it by 32. So we have, then we divide this by 1000. So we have 71.2. So let's check out 14. Let's check out 14. So this is 14. 14 is bottom reinforcement. So let's identify the reinforcement. Okay. So this is the reinforcement. So let's get the shape out. So this is the shape. So we have been able to identify the shape. Okay. So let's get the length of that shape. Length of the shape is 7575 plus 300. Okay, plus 300, then we subtract 20 from it, minus 20 over. So we have 7855. 7855. Okay, we have 7855. Then here we have 1000. So when you add it up, you have 8565. So 8565 times 40. That is, the number in each is 20. Multiply that by 2, you have 40. So 8565 times 40. You divide this by 1000. So you have 342.6. So you can approximate that to 342. You can approximate this to 342. 343. Okay. 343. So we are done with 14. The next one is 15, and 15 is Y10, which is distribution. So we would adopt the same method to calculate the length of this reinforcement. So here we check the overall span of the slab, center to center, which give us 5550. So you subtract 2000 from it. Subtract 5550 minus 2000. So you have 355. You have 355. You have 355. Okay, I think there is a repetition here. You have 355. Now, since we have 355, meaning that it is the same length, the same diameter, the same length, the same diameter. So what we will do here is that we will change this to 4. We change this to 4. We change this to 4. Then let's check out the number that we have. This is this one. The number here is 16. So 16 plus 16 plus 5. So this will give us 21. 21 times 4. 21 times 4 give us 84. So we have 84. 84 times 3550 divided by 1000. So this will give us 298. 298. Okay, so here this will become the bar mark here will change to 11. The bar mark here will change to 11. Let's go back and check. Okay, no, 9. Now bar mark will change to 9. 0, 9. Okay, 0, 9. So this one will change to 15. 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 Okay, so let's look at 15 here. So this is 19. Y12 19. Y12 19. So 15 now become diameter 12. Diameter 12. Diameter 12. Two number dots. So what are the numbers of reinforcement? 19. And it is bottom reinforcement 19. So number in each is 19. Okay, number in each is 19. So this will give us 38. Okay, 38. Let's check out the shape of that reinforcement. So the shape of this reinforcement is this. The shape of the reinforcement is this. So let's create this. So 4050 plus 300. 4050 plus 300 minus 20. It was 4330. 4330. 4330. Okay, 4330. Then here we adopt 1000. Now let's calculate 0.5. 405 times 0.15. So we have 60. Okay, so let's check out something here. Now since this is just the distribution bar, only distribute this returning bar, which is from here to here. So here we can adopt 700. This is 607.5. So you move to the next whole number, which could be 650 or 700. So in this case, let's adopt 700, since it has only one span for the distribution. There's only one span for the distribution, so we have here 700. So when you add this up together, you have 110. So let's quickly calculate the total reinforcement. Total reinforcement will now be 88 times 4110 divided by 1000. So this will give us 156. Okay, so this is basically how to calculate bar bending schedule in a slab. I think with the extent that we have gone, you will be able to finish the remaining part of it. It's just this, you use the same approach. I think I've been able to identify all the shapes that we have identified: the L shape, the straight shape, the U shape, where you have the returning bar on both sides. So I think we have been able to identify all the shapes that do occur in a reinforced concrete slab. So in our next model, we will take bar bending schedule for beam, staircase, and I think roof concrete fascia. So thank you very much, and I want to use this privilege to remind you, if you have not subscribed to our YouTube channel, I want to encourage you to do so. Thank you. God bless you. So thank you for watching. See you in model 17.